What I'm going to do, let's do a distance problem, and we're going to do it to two locations. So we're going to do let's do a shipping problem. Okay, so we're a shipping company now, right? Okay, and in fact, let's be Walmart. How about that instead? This will be more fun. Walmart. Walmart has multiple stores. Okay. All right, and the stores have locations on a map of X and Y, right? Okay, the random number function returns a random number between the values of 0 and 1, okay? Whoops, what's the text? Yeah, okay, now I'm doing it right. All right, so I'm going to do this. This will be fun. I want the X's and Y's to be between 0 and 50, so I'm going to do this. 50. Control C. I'm going to populate the whole thing, and then I'm going to copy that. I'm going to paste special and paste just the values because I don't want those random, because the random function will continue to re-randomize over and over and over again. Okay. In fact, I'm going to do something else too. I don't want all these decimal places. Y'all are going to see all kinds of functions today. So I want a value between 0 and 50. I want to round it. There's my number, comma. I want no decimal places. Pop. There we go. Pop. Now, every time you make a change in a spreadsheet, the random number generator will run again. Okay, I don't want it to do that over and over again. So now that I've got my set of random numbers for my store locations, I'm going to paste special. I'm going to keep just the values. Boink. Now those formulas are gone. Okay. So all I did right there, I wanted to create 10 random locations on a map for you guys, and I used the random number generator to do that. So there they are. Okay. Walmart then wants to decide they're going to build, how many DCs do we want? Let's make this. So we have a distribution center number 1. I have a distribution center number 2. So that was in the homework to do that. It is just as easy to do it with 5 distribution centers. Okay, we're going to get to that in Unit B. So let's just do this. So what I want to do is find out what's the X location and Y location for these 2 distribution centers, right? So I'm going to come back here. I'm going to highlight that, make it easier to find. Okay, so this is my data. There's my distribution centers. Okay, let's also weight this for something. Let's do it for trips, just like it was in the homework set. Okay, so let's add a number of trips. I should have done this all at once. So now again, I'm going to create some random numbers of trips. I'm going to round. Use my random number generator. I want between 0 and 70 trips. Because Walmart's busy. Uh-oh. Round, rand. Okay, yeah. I got to finish. There we go. Got to finish my formula. Populate it. And again, I only did that just so I can give you guys a random number of trips. There we go. Okay. Now, let's add another constraint. Okay. Because in the homework, there wasn't another constraint. Okay. What do we want to do for a constraint? Let me look at my other screen for a second, see what I want to do for a reasonable constraint for you guys. That's very similar to what you're going to encounter on the exam. Okay. So I don't want since I'm using random numbers, I may end up with an unsolvable problem here. Let me think for a second. So all between 100. I don't want any one of these distribution centers. I don't want my finished solution Yep. So my maximum distance to any single store, I'm going to claim I did 50 there, so I'm going to claim 40 miles, right? Patience with me here. There's a possibility that I've just created a problem that can't be solved. I think that this is going to be in range. We'll play with it if not. Okay, you'll get the concepts anyway. So this is a setup very similar to one of the homework problems. And what I'm going to want to do is minimize my trip weighted distance to every single store from both distribution centers. Okay, so I'm going to start by calculating what is my distance to DC1 and what is my distance to DC2. Okay. If there was only one DC, you only have to do one of these two. Okay. And this, I'm going to use the square rooted distance like we did before. Okay. All right. Got to make sure I square root. I need two parentheses because I'm going to do x minus x squared plus y minus y squared. Do I have the right number of terms? I do. I'll take the square root of that. Okay. And that's my distance to DC1. Okay. Does that make sense how I did that?
Yes.
Okay. All right. Now, same thing. This is the DC2, but because I just copied it over, my cell references are incorrect. I'm going to manually move them just so you can see what I'm doing here. My distance to the DC2 works in a very similar way, right? Okay. Now, if I want to copy these down the page, I've got to make sure my DC reference up here doesn't move. So my items in cell 4, I'm going to $sign those dudes. And this time in one's in 5, I'm going to $sign those. So I don't want those to move. So I've frozen those cell references. Okay. Now, and I like to do this again, so my numbers will do something, so I can see if something's happening. Okay, so I'm just going to pick a random spot to put those two DCs to see if this makes sense after I copy it down. They should all be different distances, right? Yep, they're all coming up different because they're all different distances from those. So this is each store's distance to DC1. This is each store's distance to DC2. Okay. Now, before we continue on, I'm going to go ahead and build in a constraint. We said the maximum distance to any single store is 40. So I'm going to just jump down here and I'm going to put in a maximum term. So my max in this case to any given store from that DC, we currently have one at 52. Oh, wow. Okay. And we currently have one here at 46. So this will be interesting if Solver can come up with something that makes sense. Okay. So that's our maximum distances we're going to have to constrain here in a minute. Now our final term we need to add on is our trip weighted distance to the store. But first, we're going to do something that a few folks didn't jump on mentally right away in the homework. Okay. So I'm going to calculate this. I'm going to say which DC is that particular store closer to, and how close is it? Okay, so I'm taking the minimum between DC1 and DC2 for store number 1. So I'm going to hit enter. There it is right there. Okay, so and we can see logically this makes sense. DC2 is 42 miles away. DC1 was 45 miles away. The minimum distance DC is 42 miles away. We could write a little formula that helps me flag which DC is that. Okay, just using our eyeballs, we can see that in this case it was DC2. Okay, we can put an if term in there and build a flag. We don't need to though. We just need to know that one of them is closer, and we only want to optimize the one that is closer. If that makes sense. Does that make sense before I go on? At least some sense. So those are my minimum distance DCs. There's my closest. Okay. Now that I know that I've got a close one, because I only care about the weighted trip distance for the closest one. So now I'm going to do a distance times my trips. Okay, so that minimum distance one, now I'm interested in, because I have 39 trips, what is that? Okay, I've got 1644 total trip miles for that particular store going to that particular DC. That's a distance per trip, and what I'm wanting to minimize is this. Oops, sorry, I said minimize, and what I wanted was a sum. I was minimize the sum of all these trips. So imagine this business problem. What it is I want to make sure that I put the two DCs in such a place that by the time every truck drives every mile for every trip, the total number of trip miles is as small as possible. That's my optimum place to put those two DCs. Okay, and I'll flag this way. Oh, not trip. And yes, I make more typos when I'm teaching live than I do when I'm doing it by myself. All right, now that we've built our model, is everyone fairly comfortable with how I got here?
Yes, I think so.
Yep, all right. So now we're going to open our solver. Okay, hit reset all, because even though it looked blank, sometimes it's got stuff hiding in there. Okay, so actually I'm going to back up. Before I do that, I'm going to go ahead and highlight this cell. And I will attempt, before I post the homework solutions, to go back and make sure everything's formatted very similarly from spreadsheet to spreadsheet. All right. So as a business person, I know I want to minimize that right there, that total trip miles. I'm going to do it by letting Solver change both of these DC locations subject to the constraints. Okay. And we don't have very many constraints, right? So if I hadn't put this minimum distance to any store constraint in there, then I wouldn't have to do this. I would just run it and see what happens. And sometimes it's kind of interesting to run it without the constraint and see. In fact, you know what, I'm going to do that just out of curiosity. Yep. Oh, so the constraint is going to be interesting. So in the natural solution here, it does have one store that would have been more than 40 miles away from a DC. So this is actually an interesting constraint to add. So I'm going to add the constraint that my maximum distance to DC1 must be less than or equal to that arbitrary 40 miles I picked earlier. And my maximum distance to DC2 must be less than or equal to that arbitrary 40 miles I picked earlier. Okay, so before I hit solve, at the moment, the sum of the distance times trip was 3,347 miles. We'll see if it makes much of a difference by putting this one constraint on there. Yep. So now the total solution is slightly less optimal in order to make sure that that one store doesn't get left out in the cold. Okay. And this is kind of important because in the business world, yes, you're trying to optimize something, but there may be something else that's important to optimize too. I'll just show you what happens here. Let's say theoretically, we as a business, Walmart says, I'm going to start using electric over-the-road trucks. But pulling heavy loads, those electric over-the-road trucks are only efficient for 30 miles. And again, I may be making something unsolvable now, but I'm going to claim now I want every store within 30 miles of a DC. That's what I just did there. So if I run my solver again, and right now we're 3,376 total trip miles on the solution. We're going to solve it. Say okay. Yep. Now we're at a place that total miles driven is going to be higher, but I can go to electric trucks because every store is within 30 miles of a DC. So that makes sense of what I just played with there.